everyone, and welcome to lesson 32 of Conquering Algebra 2. Two concepts that we're going to talk about in this lesson. One is congruency and the congruency of triangles and finding missing sides with things like that. And then the second part that we're going to talk about first is the quotient theorem for roots. So let's get into it. If we have the square root of 3 over 7, what we need to visualize that as is the square root of 3 over the square root of 7. And from there, we've already learned a couple of lessons ago that we can't have square roots in our denominator. So I need to multiply this fraction by the square root of 7 over the square root of 7 because it's something times itself, which equals 1, so it's perfectly legal. So when I do that, my denominator becomes just 7 because these would end up being the square root of 49, and the square root of 49 is 7. And then in here, I'm going to multiply my two roots together to get root 21. And so that is my answer. Okay, so in our second practice problem, they're wanting us to add these two fractions, but first we need to resolve the root situation. So this is root 2 over root 5, so we're going to multiply it by root 5 over root 5, which will give me the square root of 10 over 5 plus, and then here we have root 5 over root 2. So I'm going to multiply it by the square root of 2 over the square root of 2. So this fraction will be the square root of 10 over 2. But they still want us to add. So now we need to get common denominators and multiply these fractions to make those balanced and equivalent. So our common denominator is going to be 10, which means I need to multiply this fraction by 2 over 2. So we get 2 square root 10 plus, and then this one I need to multiply by 5 over 5. So then we have 5 square root 10. And once I get to that part, I can see that I can add these two roots together. So this is going to be 7 root 10 over 10. So there we go, we've done it. Okay, our last practice problem for this concept, the way that they have made this even deeper is now we also have a whole number in front. So what we do is we take that whole number and we put it in our numerator. So this will be 3 root 3 over root 7. And then for our next part, we're going to say 5 root 7 over the square root of 3. And then we're just going to keep going like we have been. So this is going to be multiplied by root 7 over root 7, which will give me 3 square root 21 over 7 minus, and then this gets multiplied by the square root of 3 over the square root of 3, which will give us 3 in our denominator, and then 5 square root 21. Got to get our common denominator, so this is going to be multiplied by 3 over 3, and this is going to get multiplied by 7 over 7 to give us a denominator of 21. And so now we have 9 square root 21 minus, and then 5 times 7 is 35 square root 21, and we can add our like terms. Denominator stays the same as 21, and then 35, negative 35 plus 9 is positive 26. So 26 square root 21 over 21, and that is our answer. Okay, so before we get into talking about finding the missing sides and missing variables within two congruent triangles, there was something that I wanted to mention with us naming these triangles whenever we do get to the proofs part of this book. When we have two congruent triangles, the way that we name these triangles, so let's say this is triangle ABC, is congruent. The way that we say that properly is whichever angle is congruent to angle A gets listed first because A is first. So this would be triangle F and then DE. So it's important to remember that we list them in the same order because that tells us also this angle is congruent to F, B is congruent to D, and C is congruent to E. So that's an important thing to remember. Don't forget that. Also, don't forget that these corresponding sides are congruent as well. And that's going to come into play as we talk about this lesson. There's an old geometry phrase that we used a lot when solving proofs, and that was CPCTC. And it's corresponding parts of congruent triangles are congruent, meaning corresponding parts, these are corresponding parts of congruent triangles, so these two are congruent as well. So now that we know that, let's do a practice problem. Okay, so here we have two congruent triangles. We see that because we know that this angle is congruent and this one, and because we know that AA is congruent, or because we know AA, we also know AAA, so we also know that this third angle is congruent. Something I want to point out as we solve this, the instructions say find X and P. So they don't really care what the measurements are for this side and this side. They just want to know what X and P are. Oh, and I'm sorry, this is supposed to be P. Okay, there we go. So we see that this side is congruent. We know about angles. So now we have to remember CP, CTC, corresponding parts of congruent triangles are congruent. So I know that these two parts, they're corresponding parts because they're both that bottom part. They're both attached to angle 1. And so because their corresponding parts are congruent, we know that they're equal to each other. And we can set them equal to each other and solve for X. So we have 6X plus 2 equals 12X plus, minus 4. Okay, so because we know that, we can now solve for X. So I'm going to get rid of this by saying minus 6X, and I'm going to get rid of this by saying plus 4, and we end up with 6X and 6 divided by 6. So X equals 1. Okay, so we did the first part. We found for X, we solved for X. Now we need to solve for P. Okay, and solving for P, I see that P is only listed once here, so I need to know what is its corresponding side. And its corresponding side is a 4X plus 1. So I can set those equal to each other. So P equals 4X plus 1. Now, in normal circumstances, this would not work for us because if I have two unknowns, I can't solve and find out what P is. Lucky for us, in our last problem, we just solved for X. So I can replace X with 1. So P equals 4 times 1 plus 1. And 4 times 1 is 4, plus 1 is 5. So P equals 5. So there we go. We found X and P using CPCTC. All right, and that's it for lesson 32, working with the quotient rule or the quotient theorem for roots and fractions, and then also dealing with congruent triangles and finding missing measurements and things like that. I hope this was really helpful for you guys. Be sure to message me or leave a comment below if there's anything that I could help you with or go into further explanation. I'd love to help out to my Algebra 2 students. I'll see you guys in class.